Debunking Common Myths About Specifying Special Components, brought to you by Nason and Design World magazine. We'd like to thank our presenter, Dan Deller, for being here today. I'm Michael German, Assistant Editor for Design World, and I'll be your moderator. Just a couple of housekeeping details before we get started. If you wish to tweet about this webinar anytime during or after, you can use the hashtag DWWebinar. This webinar will be available afterwards via email and through our website, www.designworldonline.com. And we will be having a Q&A session after the presentation. So go ahead and submit your questions in the question box on your GoToMeeting control panel, and we will ask them as soon as the presenter is finished. So let me tell you a little bit about our presenter today. Dan Deller is a sales manager for Nason Automation Products Division. Dan got his start in the fluid power industry at the distributor level, gaining experience on the warehouse side before transitioning into technical sales. And as I said before, Dan will be available to answer questions after this presentation. So without further ado, I will hand the mic over to Dan, and we'll let him take over.
Thank you, Mike. I appreciate that. Thanks, everyone, for joining us this afternoon. As previously mentioned, the title of today's webinar is Debunking Myths About Specifying Special Components. Today's engineers have more choices than ever when it comes to specifying the proper components for all types of applications. There are advantages and disadvantages to choosing an application-specific component or a standard component. The decision is mostly driven by the application itself. The goal of a design engineer should be to choose the ideal component for the design and not limit this decision by what is in the catalog or what is found online. Therefore, today we will explore the strengths and appropriate applications for both standard and special components so that the design engineer can make the most educated decision when specifying the component for their designs. So now we will get into the differences between specials and standard components as they apply to specific applications. Get caught up with these slides for just a moment. Okay, so what is a standard component? A standard component is manufactured to an exact industry standard. They are very predictable in design. Trade organizations such as NFPA, ISO, and others have established specific guidelines governing the tolerances and dimensions of standard components. Standard components are generally produced in mass, more of a production run type of models with no customizations for specific applications. So when is a standard component used? Standard components are usable in a wide range of applications that don't require components to be modified or have unique considerations. They are normally chosen when space is unrestricted. Standard components cannot be manipulated or customized without additional costs, so engineers will have to design around this type of a component or purchase additional materials to accommodate the piece. Standard components are currently used in roughly 90% of the applications. So why do design engineers choose standard components? Standard components are historically the natural selection for design engineers because they have been most common and accessible. Standard components are often seen as the only option as they appear in the catalog and have been the most cost-effective and timely option in the past. However, recent innovations have now made it possible to use special components when it has been impossible or cost or time prohibitive in the past. So what is a special component? A special component is precisely designed and built to fit a specific application. There is no standard size, shape, or construction of a special component. When is a special component used? Special components lend themselves to designs where standard components don't fit or don't last within the application. Special components also allow engineers to define how they're used and are great for new designs where engineers' only limit is his or her creativity. They are currently used in roughly 10% of the applications. The why choose a component. Design engineers use special components when they need more flexibility than a standard piece offers. Design engineers can create a component to accommodate the exact needs of a specific cylinder in an application. Additionally, you may choose to specify components when you have tried a standard and it simply doesn't work. An application-specific component can solve a problem that a standard component might not be able to. So now let's explore the disadvantages of standard components. There are several disadvantages of standard components. First, the complexity and accuracy involved in today's designs require that components used are precise and fit the application exactly. Because all applications are different, design engineers often end up designing around a standard component instead of securing the exact component that they need. To make a standard component work within an application, engineers are often required to source additional materials to mount the piece properly, which increases the project and time. Components that are mass-produced and designed to a certain uniform standard are not always what will work best in the design or application, but engineers often feel limited by these options. There are times when standard components work just fine, but when they won't work, it's important to note that there are other affordable and timely options at your disposal. But first you have to understand the truth about these special components. So what is the truth about special components? The truth about special components is that special components are often avoided because there are many misconceptions surrounding them. Historically, these application-specific components have been viewed as too expensive, hard to get, and impossible to replicate. In recent years, some manufacturers have devoted resources to overcome these obstacles and address the issues today's engineers face to ensure they have the option to get the exact component needed for their application. To illustrate the changes that have taken place, I will walk you through 3 myths and facts. Myth number 1, custom components are more expensive, even cost prohibitive, than standard ones. This is false. The fact is, this isn't universally true anymore. Standard components often require extra parts to properly mount within a design, which can increase the cost by as much as 10 to 15% on a single project. Multiply that across the number of components required for a single design, that cost can increase significantly. This also requires additional engineering time and can slow down project timelines if modifications are needed. Both of these scenarios increase the overall cost of the project. Application-specific components may be more expensive on the front end, but the savings realized over the life of the piece and overall applications are significant. With a component designed specifically for an application, the design will work much better and more effectively over time. Special components can also be designed to withstand extreme requirements of your application, allowing them to be built correctly the first time and decreasing the frequency of needed replacements. Myth number 2, custom components take much longer to produce. This is also false. The fact is, engineers often find themselves designing around standard components, which on its own can add considerable time to the project. Many manufacturers are now using manual equipment, allowing them to produce smaller quantities of components, keeping them from breaking into larger production runs. This decreases the turnaround time of special components to roughly the same amount of time it takes to secure a standard component. With the right information on the front end, this process can take just as quick as ordering a standard off-the-shelf component. Choosing an application-specific component also eliminates the additional time and work spent searching for, securing, and applying additional parts needed to make a standard component fit. Myth number 3, spare or replacement parts for custom components aren't readily available. Again, this is false. The fact is, Many manufacturers can often produce spare or replacement parts for custom components in less time than it took to build the original part. Today's manufacturers have streamlined processes and utilize manual equipment that enables them to have a readily available supply of additional parts for each specialized component that they have designed and built. Some manufacturers don't even require a minimum order for custom components, giving engineers the flexibility of ordering what they need when they need it. So what's the real story? Over the years, these special components have become more affordable, more convenient, and quicker to secure. With a growing number of complex and precision applications, manufacturers are overcoming previous roadblocks, ensuring that the design engineers get the exact component that they need for their application. So how do you know which decision to make when considering standard and special components? For the purpose of this example, we will pretend that we are in a process of specifying a cylinder for your next machine. When you're designing your next machine, consider your options by asking yourself the following questions. What is the environment that the cylinder will be operating in? Is it high temp? Is it low temp? What's the environment like? Will the cylinder be subject to any type of a washdown? Will there be any kind of abrasive material in the area, such as metal shavings, grinding dust, flour, anything that could harm the cylinder? How much linear force do you require out of the cylinder? Do you have enough room for a standard component? Are you replacing an existing component that is failing? If so, it's possible to design a special cylinder to last longer in the same footprint while addressing the failure point. Do you require flexibility of adjusting the end of the stroke? Does your application require you to know where the piston is at all times? What is the operating pressure? What is the operating media? Air, hydraulic, water, brake fluid? What are you running through the cylinder? Answering these simple questions will allow you to determine whether your design will be better served by a standard or an application-specific component. In summary, we have reviewed the pros and cons of standard and special components and debunked some of the common myths about special components. The key points to remember are: design engineers should choose special or standard components based on what is best for their application, rather than compromising the end product. Standard components are often mass-produced and may require design trade-offs. With modern production techniques, special components can be cost-effective, especially when the total life cycle cost is considered. Special components can also be produced with minimal turnaround times, and a spare or replacement part can easily be available. Well, thank you for your attention. Again, my name is Dan Deller, and don't hesitate to contact me if I can assist you in any way. Also, please visit NasonCylinders.com to request a free sample of a Nason design cylinder so you can see the difference yourself. Thank you.
Thank you, Dan. That was a very informative webinar. We will now open up our Q&A session here. So, first question is, how have manufacturers changed their processes to allow for quick delivery of special components?
Well, Mike, by not committing or trying to run everything through CNC program type of machines, it really allows a company to be flexible if you use manual equipment. Manual equipment, it's easier to set up than a CNC, and it just allows you to run those small quantities through in a hurry.
Okay. If I'm comfortable with my suppliers, why can't I just design my machine with their standard components?
Read that again for me, Mike. I'm sorry.
Okay. If I were comfortable with my suppliers, why wouldn't I just design my machine to use their standard components instead of the specially designed ones?
Well, if you're designing everything around a standard component, It could potentially take more time to actually complete the design because you are trying to work from somebody's catalog standard, where if you took a special component, or in this case a special cylinder, we could design that cylinder basically around what the customer is trying to do and make it easier for them to utilize. They're not going to spend the engineering time on the front end. They're not going to have to make other components to make ours to make it work.
Okay. And are spare parts readily available for, or are there long lead times for those since these are special pieces?
All I heard from you, Mike, was about long lead times and specials. Is that kind of the question?
Yeah, like for these special components, do you have spare parts readily available, or is there sort of a long wait time for getting replacement parts?
Yeah, well, it's kind of funny because believe it or not, a lot of specials are made up of standard components. So a lot of the just how you mix and match them and maybe modify one or two of them. So I would say that yes, a lot of the components for specials are readily available off the shelf, sure.
Okay, and what about minimum orders? When I order a special component, is because I don't need a lot of them. So is there like a minimum number that you need to order in order to get parts?
Yes, sir. The minimum order would be one of anything. It could be an O-ring. It could be whatever. There is no. Yeah, that will vary between manufacturers, but for some there are no minimums.
Okay. All right. We'll put the last question out there. If there's any more questions that you'd like to ask Dan, go ahead and submit them now. I'll give that a second here. Okay. All right. Thank you, everyone, for attending today's webinar. As a reminder, this presentation will be emailed to everyone in the next 2 days, and will also be available on our website at designworldonline.com. If you'd like to if you'd like to discuss this topic further, feel free to stop by engineeringexchange.com, a site for engineers only. Just go ahead and log in, ask your questions, and we will try to get answers to you as quickly as possible. Thank you. And our being here.
Okay, thank you, Mike.